Okay. Oh, sorry. I am back up. Here, ray model of light. Okay. So just carrying on from yesterday, we're looking at how light moves. Okay. So we talked about it yesterday. Light travels in a straight line unless it is changed by the medium it is in. So recap, a medium is a substance or a material that carries the wave. Okay. So I want to say optical density changes, which allows and affects the speed of the light and the direction the light changes when it enters a different medium from one media to another media. It can change direction because of the substances will allow the light to travel either slower or faster. Okay, and that's what we're going to get into later. But got off topic there again. So light travels in a straight line unless it is changed by the medium it is in. Doesn't mean it's not going to travel in a straight line. It just means that when it goes from one medium to the other, so say it's going from air to water, it's not going to not travel in a straight line when it goes to water, but the line from the air to water will not be straight. So there will be a bend, okay? So it will bend at the surface of the water, but then it will continue in a straight line. Hopefully you understood that, okay? It will bend at the surface of the water in a certain direction, whether it's slowing down or speeding up, but then it will continue on in a straight line. Okay, so how light moves, okay? So as light travels, it scatters and loses energy the further away from its source, okay? So light is released and spreads in all directions. This is why the entire room becomes filled with light, okay? And in this, you got two different examples. We have an open light bulb, which allows the light to go wherever it can. Here with the flashlight, it's only a section that the light is going into because the sides of the flashlight are preventing the light to shine out over this way or this way, okay? Okay, let's keep going here. Ray model of light. It is hard to draw light. This is where scientists have developed a way to model light, okay? This is what we're going to spend the next couple of days on. This is where we get into ray diagrams, okay? So the ray model of light is represented as straight lines, and these are called rays. Okay, ray diagrams show the path the light takes after it leaves the source. And our ray diagrams we're going to be looking at is after it leaves the source, and then it hits mirrors or lenses. Okay, that's what we're going to be looking at. What light does after it hits mirrors or lenses. So ray diagrams can help describe what happens when light strikes an object. And again, what I just said was we're looking at mirrors and lenses. Light will travel in straight lines until it hits something and it can be reflected, transmitted, or absorbed, okay? So let's talk about each of those. So transmission, so transmitted. Light passes through the object, okay? Examples, air, okay? Clear glass, pure water, alcohol, some plastic foils and containers, like sandwich wraps, acrylic glass, and some minerals, diamonds. Okay, so light is able to transmit through it. But again, like I just mentioned, because of the substance change, so the medium change, light is not necessarily, with the rays of light are not going to be straight. So they will go through, but they'll come out at different angles than they entered the substance at. Okay. Reflection. So this is just when light rays bounce back off of the object. Okay, so reflection examples of that are glass mirrors, surface of water, most metal surfaces, and generally by bright shiny objects. Okay, so reflection in the mirror. This is why you can see you. Might not make sense right now, but we are going to talk about plane mirrors. Okay, and that is the first thing. The first ray diagram you're going to be doing. But a mirror actually acts the same way as this. Now, the light rays, okay, here, this is a reflection in the water. We can see the reflection of the mountain and the trees clearly only because the water is calm. So it's acting as a mirror, okay? It is, if it was a wavy day, like a windy day that caused waves, the light rays would be scattered all over the place and they all wouldn't meet our eyes perfectly, like off of a flat, off of the flat surface. Okay. Why can we see reflections in the water? Well, because the light ray from, say, this point of the mountain here, okay, is being reflected. So just so you know, everything is reflective, okay? Except for objects that are black. They absorb everything. That's why they're black. That's the color that they are, is black. But we can see everything because light rays are bouncing off these objects and meeting our eyes, okay? When you can't see anything, that's when there's no light. So in the dark, right? When your room is dark at night. Even sometimes, you know, you can see things at night. Your eyes can adjust because there is always a little bit of light getting in, whether through your window, from the moon, that's non-luminous, that's just reflecting. But are the street lights or something is causing a little bit of light that allows your eyes to adjust, okay? There is a few situations where there is absolutely no light, all right? When I was in Iceland, we went down into the volcano tunnels, okay? And the tour guide took us down with a light, and he turned the light off, and it said, this is an example of absolute darkness, because we were in these volcanic tunnels, and when he turned the light off, your eyes never adjusted. So it was always pitch black. So you're waiting, and it almost starts to play a little bit of a mind game on you because you're waiting and nothing is adjusting, and it's just this pitch black, complete blackness. And I actually had to close my eyes, and because I was finding myself being like, all of a sudden, you couldn't tell where the ground was and like the ceiling was, or of the top of the cave that we were in, the tunnels. And it kind of messed with your brain a little bit because you're trying to get a grasp of where everything was, and you couldn't because of the total darkness. But that's what it is. Like, you can see things in your room, you can see, because everything is reflecting light off of it, and that light being reflected is coming to your eyes. Okay. I may have just gone really a lot of information there, but that's okay. Absorption. So light is lost. Okay. So again, what is this an example of? What's an example of absorption? Black, right? Black objects, they absorb light. That's why they're black. They're not reflecting. It's the absence of reflection, the absence of color. So optical properties of materials. Okay. So depending on how light is transmitted through an object, the object can be either transparent, translucent, or opaque. Okay, now let's go over what these are. So transparent objects. A transparent object transmits most of the light unaffected. So only a small light is either reflected or absorbed, but otherwise all the light goes through, so you can see it. Translucent. This object transmits some of the light. Part of the light can be absorbed or scattered. Okay, so objects like stained glass windows or wax paper you'd use for baking, maybe some tissue paper, right? So some of the light is getting through and some of it is not. Okay. All right. So opaque objects does not transmit light. There's nothing going through. Okay. So last little part is on shadows. We're not spending a lot of time on shadows, but just to go over that there is two types of shadows. And we're just going to go over quickly what they are. A shadow occurs when an opaque object blocks the direct light from a light source. So the size of the shadow depends on the size of the object blocking light and distance from the light source. Okay. Now, we usually do a gizmo on this, so you can kind of play around with it, but we just don't have the time for that. So example here. So you have a small point source of light. So here, so like say, like a little laser beam. Okay. And you throw an opaque object in front of it, it's going to completely block all of the laser beam light rays. And it's going to have this crisp shadow. When all of the light rays are blocked, that's called an umbra. Okay. So part of the shadow in which all light rays from light source are blocked. Okay. Now we have a bigger light source that has a lot more rays of light coming out. Okay. We have the same opaque object in the middle. Okay. And here, this part here, this dark part, is where all the light rays have been blocked from this light source. Okay. But then we now have these side shadows here. This is where shadows are when the shadow isn't super sharp. And this is because some of the light rays have gone through and some of them have not. Okay. So when not all of the light rays have gotten past that object, you get the fuzzy edges. Okay. Now, just if I can do this, I'm going to try this right now. And if it doesn't work, it doesn't work. Yes, it did work. Okay. So I just want to quickly show you something here. So what happens, and this might be, this is my light bulb. So what happens is, say, this is our object here. Okay. So from this light ray, this point up here, okay, let's say with the top of the light, okay, this is the top of the light we're looking at. There's going to be light rays that go from this part here, okay, that go here, that go here, that go here, here, here. So this light here, again, remember the light rays travel in straight lines, but they're traveling in all directions. So again, I don't need to do all the arrows. I know my artistic abilities are terrible. But it's shining out all of these light rays. Okay. So if this is our object, okay, these light rays are going to hit the object. Let's make that object just a little bit bigger. This light ray, that way, so they hit the object. They're blocked. Okay. Now, these light rays that are traveling out are not hitting the object. So they're going to keep going here. Okay. So these ones are going to keep going out here. All right. So these ones have been blocked. We're getting a shadow here from all of the light rays that are coming off here, off this light. We're going to have this shadow. Okay. Sorry, this is not a clean picture, but hopefully you're following along. So you get this shadow. Here, I'll switch to green because it kind of is like a mixture. All right, so these light rays have been blocked from the middle of the light bulb. This top of the light bulb has sent light rays this way, which have gone through, has sent light rays this way, which have gone through, has sent light rays here that have been blocked. Now we're going to go to the bottom of the light bulb, okay? So it's too going to send out light rays in all different directions, okay? So the ones that are hitting here are fully blocked. These ones that are going off the side here are getting through. These ones that are going off the side here are getting through, okay? But only certain ones from here. See, this is now blocked. This is blocked. So only because some of these ones are blocked, some of them have gotten through. That's where we get the penumbra. Okay? So these ones that are all blocked, all blocked, all blocked, all blocked. But then this one gets through. So it's allowing some light here. But because these light rays over from the top here have been blocked, we're only getting half the light rays through that are shining from the light bulb. So that's why there's a penumbra here, is because half the light rays have gotten through, half of them have been blocked. So because this object was in the way of some of these light rays coming, so it hits the object, all of a sudden it does get through. We still have half of the light rays here, but half of them have been blocked. So that's where you get the not as dark shadow. You get the penumbra instead of the umbra, which has blocked all of the light rays, but then you get some that go through, and that is your penumbra. Okay, so hopefully that makes a little bit of sense. What I want you to take from this, though, and we're not going to spend a lot of time on this, is that umbra shadow, penumbra shadow. Umbra is the darkest part. Penumbra is that fuzzy shadow on the side. Sometimes you won't have a penumbra. You're not always going to have a penumbra when you have a shadow, but you will always have an umbra. I hope that makes sense. Sorry. Okay, let's keep going here. So last thing on this is reflection of light. So light reflection depends on the smoothness of the reflective surface. We have a smooth surface, like a mirror, you're going to get a crisp reflection, or like the water in that picture I showed you. Sorry, my mouth is dry. Okay. Rough surface, you're going to get a diffuse reflection. And this is where all the light rays are scattered everywhere. So smooth, the water was smooth. And because of that, the light rays were bouncing off the mountain and the trees and meeting our eyes. Okay, so light rays hitting the mountain, hitting the trees, they're reflecting their light rays, bouncing off the water, hitting our eyes. And it's because of that, it's because it's bounced off the water and traveled in this straight line and hit our eyes that we can then see the mountain and the trees in the water. We can't see them on this type of water over here, the wavy water, because the light rays are all bouncing all over the place. So some will meet your eyes, and that's where you can get glimpses of the green from the trees, but you're not going to get that clear reflection as if you were when the water is nice and calm on those mornings when you take the paddleboard out. All right. So there we go. So diffuse reflection. So rough surfaces consist of a large number of different specularly reflecting planes. Okay. So you have the light rays going all over the place. Visible light reflects diffusely from paper. Okay. So paper is not a smooth surface, actually. It's all a bunch of fibers. So here we go. So another example, right? So what kind of reflections account for the column of light reflected off the water? What would we see on the water if it were perfectly flat and unmoving, right? Wavy. We're not getting that clear reflection. Clear reflection, right? When you can see like the moon in the water at night, right? That clear, crisp reflection when it's calm, when the water's calm. We are not doing those textbook questions, and you're not doing the gizmo. And that is the end of that one.